Hi ladies, this is Mrs. Blaufuss here. This is lesson 1.1, building blocks of geometry. So this is a lot of definitions. So we're going to go through some of those definitions, give you some visuals on how to appropriately represent those definitions in diagrams. So the first one is point, and you'll always see point labeled with a capital letter. When we're talking about a point, you'll just see a dot and a capital letter. And something about a point is that it does not have a size, but it marks a location. So there's no size, only a location. Lines, as you can see, are represented with arrows. So this line AB, it's straight. It goes on forever in both directions, and it's labeled using 2 points. So when we mark lines, we have that the arrow on both ends of the segment to mark line AB, or if you say line BA, that is the same thing. Okay, just it's a different way of naming the exact same line. So lines are straight. They're a continuous arrangement of infinite many points. And it goes on forever in both directions. But there is no length or thickness. The length is infinite. It goes on forever. So you can't say that a line is, 3 centimeters long. There's no way to measure the length because it goes on forever. Planes, you'll see planes marked as this parallelogram with a script capital letter. So this is plane P. Planes have length and width, but there is no thickness. Planes are made up of 3 points, whereas lines are made up of 2. So there can obviously be more than 2 points on a line, but you need at least 2 points to form a line, and you need at least 3 points to form a plane. The term collinear, co means together, so together on a line is collinear. So those are points that are on the same line. And coplanar, again, together on a plane. So points, in this case, points E, D, and F, points that share the same plane. And then the next term is a line segment. So you can see in this diagram, see here we have points A, B still, but those are endpoints. Okay, so a line segment does not go on forever in both directions. It just goes from endpoint A to endpoint B. So a segment, or a line segment, consists of 2 endpoints of the segment, and all the points in between them that are collinear with the 2 points. So we could have a point D, we could have a point G, generally label those with capital letters. So we'll call this point G. I don't know, this could be point Z. So all of those points are on the segment AB. And we call segment AB by just putting a line without arrows above the 2 endpoints. You can measure a line segment. You cannot measure a line. Okay, so we can measure segment AB, or we can measure segment AC, we can measure segment BC, but we cannot measure this line. Okay, if it has arrows going in both directions, that means it goes on forever. So we have a property called the segment addition property, and it says that if points A, B, and C are collinear, and B is between A and C, then segment AB plus segment BC is equal to segment AC. This is called segment addition. Some ways you may see segments being measured is either AB, that says the distance between those 2 points. So that's segment AB right here. A to B is 2 inches, or you also may see this M. Okay, that M means measure of segment AB equals 2 inches. You may also see it on a coordinate plane. And this says that MN, again, the distance between point M and N is 5 units, or the measure of segment MN is 5 units. So let's look at an example using segment addition. It says Podunkville, Smallville, and Gotham City lie along a straight highway with Smallville between the other 2 towns. First thing we're going to do here is we're going to draw a diagram. So it says that they lie along a straight highway. That indicates that it's comparable to a segment. That's how we can display that in our diagram. And there are 3 cities that lie along this highway: Podunkville, Smallville, and Gotham City. S stands for Smallville, and Smallville is between the other 2 towns. It doesn't say exactly between, it just says somewhere in between those 2 towns. So the question is, if Podunkville and Smallville are 70 kilometers apart, so let's label our diagram 70 kilometers, and Smallville and Gotham City are 110 kilometers apart, how far is it between Podunkville and Gotham City? We're going to use segment addition here. So if P, S, and G are all collinear, which they are because they're on a straight highway, then the distance between PS plus the distance between SG is equal to the distance between P and G. So PS is equal to 70 kilometers. SG is equal to 110 kilometers. Together, they equal PG, which is equal to 180 kilometers. Now we used equal in that last example, and we use equal when we're talking about number, like numerical values or distance. Okay, so when we have numbers, we use equal. A term that means equal, but we're using diagrams, there's no measurement, is congruent. So we use congruent when we talk about figures. So this is the sign for congruent. It's that equal sign with that little squiggle above it. And we use that when we don't have measurements. When we're marking a diagram, we use these little tick marks, they're called. And the one single tick mark in between each segment means that those 2 segments are congruent to each other. In this next diagram, we can see it's a rectangle. Here we have a pair that has 2 tick marks, and then another pair of segments that has 3 tick marks. That means the 2 tick marks, these 2 segments, SP and RQ, are congruent, and the ones that have the triple, these 2, SR and PQ, those segments are also congruent. Okay, so the tick marks need to match up in order to show that segments are congruent. This lesson is pretty heavy in terminology. So the next term that we have is that a midpoint bisects a segment. And the midpoint is a point on the segment that is equal distance from both endpoints. So a midpoint has to be on a segment. You cannot have the midpoint of a line because, again, line does not have endpoints. It goes on forever, so there's no way to cut it exactly in half. By bisect, we mean cut into 2 equal pieces. So let's look at the diagram below. It says, name each midpoint and the segment that it bisects. So when it bisects, again, we have to know that it cuts it into 2 equal pieces. Okay, so in this first diagram, the midpoint is right here. It's F. F is the midpoint because F is directly between point C and point D. We cannot say the same thing about F being the midpoint of EG because we don't know how far these points are. It looks like it's probably in the middle, but we don't know for sure. And in geometry, if you don't know for sure, you cannot draw that conclusion. So we can't say that F is the midpoint of EG because, again, we don't know how far away F is from E and how far away F is from G. It has to be exactly the same distance. Okay, in the next diagram, the triangle, we don't know how far this is. We don't know how many units it is, but we know that K is the same distance away from L as it is from J. So we can say K is the midpoint of JL because it is exactly the same distance from J as it is from L. And in the last one, we don't know that N is a midpoint. So we cannot say that N is a midpoint. In the second part of this question, it says name all congruent segments. Use the congruence symbol to write your answers. So if we have a midpoint, then we have at least two congruent segments. So in the first diagram, we know that CF is congruent to FD because F is the midpoint. And it doesn't matter if you say CF or FC, it's the same thing. Both are endpoints of the segment. So we know that CF is exactly the same length as FD. So those 2 segments are congruent. We do not know anything about the length of EG or EF or FG, so we cannot draw any congruence conclusions from that diagram with those specific points. In the second diagram, here we see these little tick marks. So we know that HJ is congruent to HL. Again, we don't know the distance, we don't know the measurements, but we know that they're the same. Okay, and the second piece, because K is the midpoint of JL, we can say that JK is congruent to segment KL. And then lastly, in the last diagram, we don't know anything really about that. So we cannot draw any conclusions about congruence in that last diagram. So just a few more definitions. The first one is that a ray begins at an endpoint and extends indefinitely in one direction, or extends forever. So you can see a couple displays of ray. You always label where your endpoint is the first letter. Okay, so we start with AB because A is the endpoint, and then we draw our arrow always to the right. In the second label, B is the endpoint. Okay, and even though the line, the forever goes to the left, it goes forever in the direction of left. When we write our label for ray, we still start with B, and our arrow in our label always goes to the right. Okay, so you always, when you label your rays, start with an endpoint and then some other point on the line. In this last example, we're going to look at labeling all lines, rays, and segments in this figure. And the big difference is the markings that you have above the points. Okay, so a line could be MA. Okay, so starting here and going forever in that direction. It could be MT. Starting at M and going forever through T and on forever. Or it could be MH. Starting at M and going forever through H. Or you could label it as AT. Again, going through A to the left, through T to the right. It could be line AH, or it could be line TH. Okay, so those are all different lines, different ways to label the same line. Excuse me. And then all of the back, like the inverse letters. So it could be like AM, TM, HM, and so on. Those will all be the same line. For rays, remember with rays, you need to start at an end point. Okay, so we could have ray MH, and we could also have ray, ray MH, where H, it goes through H and on forever, but M is an endpoint. Or a different ray would be HM. Okay, a different ray would be starting at H and going through M in the opposite direction. So take a minute and try to label all of the different rays. And then do the same with the segments. And then you can unpause the video and I'll show the solutions. Okay, so notice there are twice as many rays as there are lines. Line MA and line AM are the same line, but ray MA and ray AM are two different rays because they go in different directions. And when labeling the segments, the note above each point, or the set of 2 points, is just a segment. There's no arrows on it. And again, segment MA, that's the same as segment AM. Okay, so these are the same. But it's a different segment than segment MT because it has different endpoints, and it's different than MH because it has different endpoints, and so on. So please jot down any questions you have from this lesson and bring those questions to class tomorrow. Thank you.